Welcome to this lesson on weak bases. In this video, we'll explore what makes a base weak and understand the concept of partial dissociation when these bases dissolve in water. A weak base is a base that partially dissociates when dissolved in water. Unlike strong bases that completely break apart into ions, weak bases only partially separate, establishing an equilibrium between the undissociated molecules and the ions they form. This partial dissociation is the key characteristic that defines weak bases. The general equation for weak base dissociation is B plus H2O, which is in equilibrium with BH plus and OH minus. Here, B represents the weak base. The weak base accepts a proton from water, forming its conjugate acid BH plus and hydroxide ions OH minus. The double arrow indicates this is a reversible reaction in equilibrium, not a complete dissociation. Let's look at ammonia, one of the most common weak bases. When ammonia, NH3, dissolves in water, it follows the equation NH3 plus H2O in equilibrium with NH4 plus and OH minus. Ammonia accepts a proton from water to form ammonium ion and hydroxide ion. Notice that not all ammonia molecules react. Some remain as NH3 in the solution. The strength of a weak base is quantified using the base dissociation constant, K sub B. The K sub B expression is K sub B equals the concentration of BH plus times the concentration of OH minus, divided by the concentration of B. This equilibrium constant tells us the extent of dissociation. A smaller K sub B value indicates a weaker base. Weak bases have two key characteristics. First, they have small K sub B values, typically ranging from 10 to the power minus 5 to 10 to the power minus 10. Second, their aqueous solutions have a pH range that is slightly basic, usually between 7 and 11. This is much less basic than strong bases, which can reach pH values of 13 or 14. Some common examples of weak bases include ammonia, NH3, methylamine, CH3NH2, and pyridine, C5H5, and all of these compounds partially dissociate in water and have relatively small K sub B values, making them weak bases. The key difference between weak and strong bases lies in their dissociation behavior. Strong bases completely dissociate in water, breaking apart into 100% ions. In contrast, weak bases only partially dissociate, establishing an equilibrium between the undissociated molecules and the ions. This fundamental difference determines their strength and pH behavior in solution.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.